Graphing linear inequalities. A linear inequality is similar to a linear equation, except that a linear inequality has an inequality symbol like less than or greater than instead of an equal sign. A solution of a linear inequality is any ordered pair that makes the inequality true. You can evaluate an inequality with an ordered pair to find out if it is a solution. Let's get practice doing that. Is 0, 4 a solution to this inequality? Well, we'll substitute 0 in place of x and 4 in place of y. We'll simplify and evaluate. We notice the statement is true, therefore 0, 4 is a solution. Okay, let's substitute in the second example 3 in place of x and -3 in place of y. And we'll simplify. And we get -3 is less than -3. That is false. Therefore, the ordered pair 3, -3 is not a solution. Okay, so we're going to be doing a lot with graphing in this lesson. And we'll start by looking at a linear inequality and learning how to graph it by hand. We'll start by graphing the boundary line using a solid line because the inequality contains the symbol greater than or equal to. So you know our y-intercept is going to be -3. Our slope is -3/4, so down 3 to the right 4 from the y-intercept. Next, because of the symbol greater than or equal to, we're going to shade above the boundary line because we want all y values that are greater than those on the boundary line. So a lot of books, you'll see something about a test point. In this video, we'll make sense of the direction of the inequality instead of using a test point. All right, let's do another example. Graphing an inequality x is less than 4. Well, first of all, we want to use a dashed line because of the less than. And this is a special case line that goes through the x-axis at 4. It's a vertical line. Now that inequality symbol is strictly less than, so we want all x values less than those on the dotted line. So we're going to shade to the left. We'll take another example, this one in standard form. Let's rewrite it in slope-intercept form. Divide all terms by 4. Let's graph the boundary line using a solid line starting with our y-intercept of 2. Our slope is -4. We want that solid boundary line. Now we're going to shade below this line because when we rewrote the equation in slope-intercept form, we want all y's less than those that lie on the boundary line. So we're shading below the line. And there is our linear inequality. Any ordered pair that is in that shaded region is called a solution of that linear inequality. We'll try another example in standard form. Here, let's rewrite it in slope-intercept form. So we'll subtract 3x from both sides. Let's divide by -1. And when we do, remember we change the direction of the inequality. So now we're going to graph y is greater than 3x plus 4. We'll use a boundary line that is dashed because of the greater than. We'll start at 4 on our y-intercept. The slope is 3. Again, a dashed line. Because we had rewritten our inequality as y is greater than 3x plus 4, we're going to shade above this boundary line. So that's some practice. Oh, and we could also use our graphing calculators, but for the most part with graphing calculators, you will need to take the inequality and write it in slope-intercept form before you type it into your y function button. All right, now, if I give you a linear inequality and I ask you to write the symbolic form, we want to think about the boundary line. Is it solid or is it dashed? In this case, it's solid. This is a special case line. It goes through the y-axis. So the boundary line itself is y equals -1. But because everything below that is shaded, its y is less than or equal to -1. Okay, the second example. We'll start with our slope-intercept form of a line. We'll notice that the boundary line is dashed. So first of all, we'll find our y-intercept. We will identify a lattice point to look for our slope. Our y-intercept is -4, our slope is 1, so y equals x minus 4 is the boundary line, but we shaded everything above that boundary line, not including the line itself. So y is greater than x minus 4 is the linear inequality. All right, in that third example, we have another special case line, horizontal line. And you could certainly think about y equals mx plus b. Notice that the slope is 0, so we're just going to have y equals 4. But because we've shaded below, we want y is less than or equal to 4. So that was a little summary about linear inequalities, graphing them and writing them in symbolic form.